Yeah, let's start it. In this session, we are going to discuss PySpark for AWS Data Engineering. In that, let's understand PySpark for AWS Data Engineering syllabus and what are we are going to discuss as part of PySpark for AWS Data Engineering. Okay, first point to do. PySpark is a data processing framework. It is a pure data processing framework. It can take any input source and it performs the processing and it can write into any output to output. So it is not tightly coupled with any input. It is not tightly coupled with any output. And the second point, it will not store any data in PySpark. It's purely data processing framework. It is a uh, massive parallel processing data framework. It distribute your data and process data in parallel processing. So as part of PySpark for AWS Data Engineering, we are going to discuss first PySpark Fundamentals team. We'll start with PySpark Fundamentals. So this is very, very important for everyone who do not have any knowledge on PySpark. This will give clear idea about what is PySpark, what are different components in PySpark, how we are going to run PySpark programs, and what are job roles available for PySpark. And then we are going to discuss PySpark programming in the introduction, how we are going to write a PySpark program. And then we are going to see PySpark installation on Windows operating system. And then we are going to see first PySpark program using PySpark shell. And next we are going to see first PySpark program using Jupyter Notebook. So once PySpark fundamentals are completed, you will get complete knowledge on PySpark, runtime environment, softwares required for PySpark, and how we write PySpark programs, how we can run PySpark programs. Once this one is completed, we are going to start very, very important one is core programming. So PySpark, we can write programs. One is RDD, means PySpark core, RDD. RDD stands for Resilient Distributed Dataset. So this is PySpark core programming. RDD programming means PySpark core programming. And then data frames. Data frames. Here we write queries in SQL approach. For this, we use PySpark SQL team. PySpark SQL. So we are going to discuss this. We implement using Python programming language. RDD programming, we write using Python programming. So this RDD programming is Python core programming. Data frame programming is SQL. In this, we learn PySpark SQL. So these two are very, very important. So first we will try to implement SQL-based solutions. If SQL is not providing complete solution, in that case, we go with the RDD. Then we continue RDD. Then we convert results into SQL. Then from that SQL part, we will continue PySpark SQL. Okay, example, I have a text data. Example, we are working for e-commerce reviews data. So we are getting complete reviews data of multiple products. multiple products. So this review data is not structured data. This data we create RDD. By loading this data, we will create RDD. Then we apply some operations. Then we convert the data in a structured form. Then we convert RDD to data frame. We convert RDD to data frame. Then we will continue SQL part. So if anywhere SQL is not possible, we can achieve that using RDD programming with Python. So RDD programming we implement using Python language. Data frames programs we implement using SQL queries. For RDD, PySpark having component called Spark Core. For SQL programming, PySpark has PySpark SQL. And next, coming to PySpark streaming, if any source is continuously generating data, we use PySpark streaming. We configure PySpark streams to read this continuous streaming data. We read PySpark streams to read this continuous streaming data. Then we apply stream data processing using PySpark streaming concepts. Once we complete these 4 topics, then we are going to see how to install PySpark on EC2 machine. So up to these 4 modules, we are going to discuss on Windows. Then 5th module, we are going to install on Ubuntu operating system. We are going to install PySpark on Ubuntu operating system. Then we are going to see how to integrate with different other AWS services, S3 and other services, how we can integrate using PySpark. Okay, total 6 important modules we are going to discuss as part of PySpark for AWS Data Engineering. Okay. Yeah. Let's continue. As part of PySpark for AWS Data Engineering, in this session, we are going to discuss what is PySpark. So first important point, PySpark is a data processing framework. PySpark is a data processing framework. It's purely data processing framework. It does not have any storage. It's purely data processing framework. It can take input from any source. It performs a processing logic. It will take input from any source. It performs a processing and then writes output into any storage. It will write output into any storage. Your input may be local file system like CSV, JSON, Parquet, XML, etc. Your input may be Apache Hadoop. Your input may be Apache Hive. Your input may be any RDBMS database. Your input may be any NoSQL. Your input may be any cloud file system. Your input may be any data warehouse like Snowflake, Redshift, Azure Synapse, etc. Your input may be anything. We give input to PySpark and it will, inside PySpark, we write a processing logic and finally we write output into any target. Target may be local file system, target may be Hadoop, target may be Hive, target may be any RDBMS, target may be any NoSQL, target may be any cloud file system, target may be any data warehouse like AWS Redshift, Azure Synapse, and Google BigQuery, and Snowflake. or any target. PySpark is not tightly coupled with any input, any output. It can take input from any input storage. It performs processing and it will write into any output location. It's purely data processing framework. PySpark is purely data processing framework. And let me add one more important point here. Spark is a software. Spark is a software. This Spark software developed using Scala language. Developed using Scala language. This Spark software developed using Scala language. This Spark software provides API, stands for Application Programming Interface, means predefined classes, predefined functions, predefined variables for 4 languages too. For Java language, Scala language, Python language, and R language. If you write Spark in Java, we call it as Spark with Java. If you write Spark applications in Scala, we call it as Spark and Scala. If you write Spark applications in Python language, we call it as PySpark. If you write Spark applications in R language, we call Sparker. Okay, and it is a in-memory computing. In-memory computing means, let's say, I have data, I have a data, and this data I loaded into either data field or RDD. Let's say I loaded this data into either data frame and RDD. It will divide your data into multiple partitions. Each partition, it will store in different machines memory. Different machines memory called RAM memory or in memory. It will distribute your data into multiple partitions and stores into different machines memory. And then it will process this data parallelly. So it is a in-memory computing and parallel processing framework. It is in-memory computing and parallel processing framework. Parallel processing framework. Okay. A clear writing, what is PySpark? Yeah, let's continue. As part of PySpark for AWS Data Engineering, in this we are going to discuss what are different PySpark components. PySpark has 5 important components. PySpark has 5 important components. PySpark Core, PySpark SQL, PySpark Streaming, PySpark Machine Learning, PySpark Graphics Programming. These are 5 important components. In that, main important component is PySpark Core Programming. PySpark Core called RDD Programming. This RDD programming we can implement using Python programming language. So PySpark has 5 important components. In this, main important component is PySpark Core Programming. So in Spark Core, we write RDD programming using Python programming language. So PySpark Core programming is lengthy, time-taking to implement. And you need to know PySpark Core, you need to know Python to implement RDD programming. So to reduce length of the code, on top of PySpark Core, they developed PySpark SQL. These are abstractions These are abstractions on top of PySpark core programming. If you go with the PySpark SQL, first point, in PySpark core programming, we will write RDD programming using Python language. Here we have a concept called transformations and actions. Writing RDD programming means writing transformations, writing actions using Python programming language. So to reduce length of the code, to write, to implement SQL kind of approach and to learn anyone, to work anyone, PySpark developed one more component called PySpark SQL. In PySpark SQL, we have a concept called data frames and table. On data frame, we will write DSL queries. DSL stands for domain specific language queries. Example, first we will create a data frame by by loading input. By loading input. Input may be file, input may be table, RDBMS, input may be data warehouse table, input may be cloud file system, input may be Hadoop, input may be any input. Then we will create a data frame. Let's say I want to display data frame. Then we write a function data frame dot select function, and here we pass select star. That's it. It will display complete table data. Whatever you created, right? It will display all rows. All rows. So here you are seeing function. So as part of DSL, PySpark people given different functions for every SQL activity. Group by, order by, filter. For every purpose, they given different SQL related functions. So we use these predefined functions to achieve our desired requirement. So next is we can create a table. First, we will create a data frame. Data frame we convert into table. On table, you can write SQL using one function called Spark session contain one function called SQL. In this function, we write our pure SQL statements. Let's say select star from, let's say table name is EMP. We converted this data frame into EMP table. Let's say we write select star from EMP. Like this, we write native SQL statements. First one, in PySpark, we have a data frame. We load data and we will create a data frame. We apply DSL queries on top of data frame. Or you can convert data frame to table, then you can directly apply native SQL queries. On table, you can apply native SQL queries. Compared to native SQL query, see this is native SQL query, and here this is DSL query. DSL queries are simple and less compared to code wise. Here you can see lengthy, here you can see less code. So DSL queries, for every SQL activity, they given predefined function. You can use that function. Let's say I want to write a condition. How we use select, where sal greater than some value, right? Similar way, they given where function. Group by, they given group by function. Order by, they given order by function. Distinct, they given distinct function. For every purpose, they given predefined functions as part of DSL for PySpark SQL. Okay. So next one, next important component is PySpark streaming. If any source you are getting continuous streaming data, PySpark having a special component called PySpark streaming. You can configure PySpark stream. You can read that data, streaming data. For this purpose, we have other components like Apache having Kafka. Using Kafka, we can read streaming data, but we cannot perform live analytics. Using PySpark streaming, along with the streaming, we can also implement live analytics. Example, credit card fraud detection. Let's say credit card transactions we are getting as input. Let's say card one, two transactions happen at a time in two different locations. Let's say North Hyderabad one transaction, East Hyderabad one transaction happen at a time. Then we can read that streaming data, we can write analytics, we can find card details, and we can find how many transactions happen that for card at the same time. We can notify client saying, hey client, there are two transactions happen in two different locations. Is that done by such kind of live analytics we can implement using PySpark streaming. And other important component is very important, PySpark ML or MLib. Using this PySpark ML or MLib, we can implement machine learning applications, or we can also call data science applications. We can implement using PySpark ML, PySpark MLib. PySpark ML stands for machine learning library. MLib also we can say PySpark machine learning library. Using this PySpark ML or MLib, we can implement machine learning applications like feature prediction applications. Yeah. Next important component of PySpark is PySpark graphics. Full form of PySpark graphics is graph data processing or linked data processing. Let me take one scenario. Let's say this is my social media data. Social media. In social media, let's take Facebook. Let's take Facebook. Let's say a user called Sreenivasa, and new user created account. New user created account called Badri, and Sreenivasa assume 300 friends are there. 300 friends in Facebook. New user created Badri, and he sent friend request to Srinivas. Then Srinivas accepted friend request. Then automatically these 300 friends get a notification saying mutual friend request, mutual friend details. Yes, sir. So how we are getting these kind of links is to process this kind of linked data. We use these kind of frameworks. Same thing we can achieve using traditional programmings like Java, .NET, Scala, and Python, we can achieve same thing. We can send a mutual friend notification for finding different friends. Let's say again, one of friend having 1,000. For these 1,000 friends also, you may get this Badri as a mutual friend information. So here we can use traditional programming to achieve this linked data processing, but here we need to write a complex programming. Complex programming, even though if you write complex programming using these technologies, you may not achieve 100% for this linked data processing. Such kind of complexity we can reduce. We can write a simple implementation using PySpark graphics programming. These kind of linked data processing we can easily implement using PySpark graphics programming. So these are 5 important components of PySpark. Okay. Oh, yeah. Let's continue PySpark for AWS Data Engineering. In this, let's continue what are different PySpark runtime environments. Let's say we developed PySpark application using any one of these components or combination of these components. Let's say I developed program one, program one.py using any one of this component or combination of all these components. Let's say we developed an application. Once we develop this application, where we are going to run? First one thing. Let's say this is my developer mission. This is my developer mission. In this developer mission, we are going to install PySpark. We are going to install PySpark. Okay, then we will write PySpark program. We will write a PySpark program, program1.py, program1.py. Then we will run this PySpark program on local runtime environment. First we will run our PySpark program on this local environment. Once this program executed successfully, then we are going to deploy this PySpark program on PySpark standalone cluster or Yarn cluster or Mesos cluster or Kubernetes cluster. Okay, let me explain. So let's say we will create a PySpark standalone cluster. We will create PySpark standalone cluster with master slave architecture. We will create maybe on premise or any cloud. We will create this one and we will deploy our program into this cluster. Or let's say we have already Hadoop cluster. Assume our organization having Hadoop cluster. Hadoop cluster. Then here we have Yarn architecture. Hadoop having a cluster called Yarn. In this also we can deploy our PySpark applications. Or Apache provides one more architecture called Mesos cluster. Mesos software. Using that, you can create a cluster. You can deploy your applications on Mesos cluster. Or Nowadays, most popular is Kubernetes cluster. Using Kubernetes, you can create a parts. In that parts, you can install PySpark software, Kubernetes cluster, and then deploy your applications into Kubernetes cluster. Once PySpark programs developed, tested into local environment. Once the development is completed, where we are going to run our PySpark applications is on PySpark standalone cluster or Yarn cluster or Mesos cluster or Kubernetes cluster team. Clear writing? What are PySpark runtime environments? Let's say this is my developer mission. In this developer mission, I tested PySpark on local PySpark software. Okay, this is my program one, program1.py, program1.py. In this cluster, they will create one client mission. They give access of this client mission. We connect this client mission using any SSH client like Putty. Through the Putty, we will connect and we are going to deploy this program into client mission. Here we are going to submit PySpark application to this cluster. Similar way, other environments. Every cluster provides a client mission. We will connect to that client mission. We will deploy our PySpark program and we will run our PySpark program. These clusters supported up to now supported PySpark runtime environments are PySpark standalone cluster, Yarn cluster means Hadoop cluster, Mesos cluster, and Kubernetes cluster. These are different runtime environments to run our PySpark applications. Initially, in developer mission, we will develop and test in local PySpark runtime environment. Once execution is completed, we are going to deploy our PySpark applications on any one of these clusters. Okay. Yeah. Let's continue. In this session, we are going to discuss PySpark job roles in real world. There are two kinds of jobs we can find in PySpark world. One is PySpark developer, and other one is PySpark data scientist or PySpark machine learning developer. So these kind of jobs we can find in real world. So PySpark developer, industry expects these knowledge. First, you must know PySpark core programming. You must know PySpark SQL. You must know Python. You must know SQL and PySpark streaming and PySpark integration with different services like RDBMS integration, cloud file system integration, cloud data warehouses integration. Industry expect these kind of knowledges for PySpark developer. If you are looking for PySpark data scientist, first you need to have PySpark developer knowledge. Then they are going to expect PySpark machine learning, PySpark graphics plus mathematics knowledge, stats knowledge, and machine learning algorithms knowledge, deep learning algorithms knowledge. We can say data science algorithms knowledge. So two kinds of jobs we can find in real world: PySpark developer, PySpark data scientist. PySpark developer industry expects these concepts, knowledge and experience. PySpark data scientist, they expect these components or concepts, experience. You may think already data science or machine learning uh, industry using Python. Why industry go for why industry go for PySpark data scientist or PySpark machine learning developer. If you go Python, it is not distributed parallel processing. And your ML algorithms compared to machine learning with PySpark ML algorithms, both are not same. Concepts are same. Concepts are same. Data processing wise, if data is small, this is fast. This is also fast. If data size going to increase, this will become slow. This will become super fast. So that's why industry go PySpark data scientist or PySpark ML developer. But this is a distributed plus parallel processing framework. Because of this distributed parallel processing framework, assume data science having hundreds of algorithms. For all hundreds of algorithms, this distributed parallel processing may not suit. So if you see PySpark ML algorithms, these are not these 100 algorithms. Whatever we can achieve using distributedness, those are presented in PySpark ML, not all these hundreds of algorithms. Okay, so if your requirement, if your requirement within that ML algorithms, you can go with PySpark data scientist. So PySpark ML is not for all the machine learning algorithms because it is a distributed parallel processing. Distributed parallel processing not suitable for every problem. Okay. So industry, we can find these two kinds of jobs for PySpark developers, PySpark technology. So if you want to become ETL developer, this knowledge is more than enough. If you want to become data scientist, learn these components also. Okay. Yeah. Let's continue. As a part of PySpark for AWS Data Engineering, in this session, we are going to discuss PySpark programming introduction. In PySpark, we can get programs in two ways. One is interactive mode, second one is scripting. Understand what is interactive mode, what is scripting mode. Interactive mode, interactive mode, interactive mode, and script mode. Script mode. In interactive mode, we write statement by statement. We run statement, we see the output. We write one more statement, we see the output. So step by step development. In script mode, we will write a program script file, let's say program1.py. In that program1.py, we write all statements first. All statements first. Later, we will run the script file. Later, we will run the script file. In interactive mode, we write a step-by-step development. Each step we will execute, we will see the output. Next, we will write another step, we will see the output. Like this, we will develop interactive mode development. In script mode, we will write all statements in one script file. We will run that script file later. So to develop interactive mode program, we use PySpark Shell or Jupyter Notebook software. Jupyter Notebook software. To develop interactive mode development, we use PySpark Shell and Jupyter Notebook. This PySpark Shell comes with PySpark software. Once you install PySpark software, you will get this PySpark cell. PySpark cell. Jupyter Notebook we have to install manually. Second one, script mode we can develop using PyCharm IDE, using VS Code, using Spider IDE. There are multiple IDE softwares available to develop a script mode development. Okay, these are two different ways developing script mode. Question is, do we use script mode or do we use interactive mode? Yes, we use both modes. Let's say I develop interactive mode statements. Then let's say in this is valid, this is valid. All valid statements I will convert into a script file. Then I'm going to deploy this script file into any one of runtime environment. Development, we use interactive mode. Later, we have all valid states into a script file. Then we are going to deploy script file into any one environment. One more important note. Let's say we have Spark core, and Spark SQL. If you want to write any Spark core programming, Spark SQL programming, first you need to create two context objects. One is Spark context and Spark session. If you use interactive mode, these two already created. Whenever you type command PySpark, these two already created. If you use script mode, we have to create these objects manually. This is very, very important. While discussing first program, we are going to discuss once again clearly about this PySpark context, PySpark session. Okay. Let's continue. As part of PySpark for AWS Data Engineering, in this session, let's start discussing PySpark installation on Windows operating system. Okay. So first, let's discuss PySpark. PySpark software, or let's say Spark software, developed using Scala language. Spark software developed using Scala language. Scala is a JVM based language. Scala is JVM based language. What is JVM based language? Let's say we developed a program called program1 dot scale. So to compile this program, we use Scala compiler. The Scala compiler reads this Scala program and checks syntax of all Scala rules. Then it will convert this one into bytecode called program1 dot class. Program1 dot class. So this is bytecode. This bytecode is understandable format of JVM. JVM stands for Java Virtual Machine. So to run this code, we need Java Virtual Machine. So to run any Scala-based software, we need JVM. Only we compile using Scala, Once compilation is completed, to run that software or program, we need a Java virtual machine. So here, understand, you need Java should be installed in our machine. Current Spark is supporting Java 8 and latest version of Java. And optionally Scala 2.x. Scala is not mandatory. If you are using Spark and Scala, then you require Scala. If you are using Python, then Python should be installed. That's it. Scala is optional. Next, Hadoop underscore home should be set. What is the purpose we are going to set Hadoop underscore home? We are going to discuss it. And next, fifth step, we are going to install PySpark into our machine. Okay, let's start one by one. First, let's start installing Java underscore Java. Let's say Java. We can download Java 8, install Java 8, and set Java underscore home path variable. Then verify Java is installed or not. Okay. So here, first I'm verifying Java is installed my machine or not. Let's open command prompt. Then check Java space hyphen version. Then if Java is present, it will display Java version. It is saying Java command not recognized. So let's open any browser. I'm opening Google Chrome. Then I'm searching Java 8 download. So you can see java.com. You can see Oracle. Java is developed by Sun Microsystems. And Sun Microsystem sold this Java software to Oracle. Now vendor of Java is Oracle. So you may see different links for downloading Java. I always recommend download Java from Oracle website. So second link, you can see Java SE8 download. Click on this link. Here, let's scroll down. You can see Java for different operating systems. Scroll down. You can see Java for x86 and x64. x64 is a 64-bit too. 64-bit, and this one is 32-bit. 32-bit. So my mission or my operating system is 64-bit. I am going to download this one. Okay. Let me click on this download. Click on this one. Then check I receive. Then click on download. Once you click on download, it will prompt login of Oracle credentials. If you do not have, create account, then later you can enter your login details. I already created. Let me enter. Then enter email ID, enter password. Then click on sign in. Then they will send notification OTP to your mobile registered in that account. Yeah. I'm entering OTP. Let me 33160168. Then click on verify. Once your login details are valid, it will start downloading. Click on start download. Yeah, download is success. Open download folder. and double click on this Java exe file. Double click on this one. Choose all default options. Choose all default options. Click on yes button. Then it is started installing. Let's wait a few seconds. Yeah, click on next button. Then click on next button. Then it will start installing. Let's wait a few seconds. Yeah, click on OK. Click on next button. Then it is continuing installation. Let's wait a few more seconds to complete installation. Installation almost completed. Yeah, completed. Click on close. So go to installation location. Double click on this PC. Yeah, click on C drive. Then here you can see program files x86. This is 32-bit. And program files is 64-bit software's installation location. Okay, let's go to program files. Here you can see Java. In this you can see JDK 1.8.0 means Java 8. Here bin you can see all Java commands. To make this Java commands available from anywhere, we are going to set Java underscore home path variability. Okay. So before bin path, copy Java path, copy this path. Okay. Click on this PC, right click on this one, click on properties. Then click on advanced system settings. Here click on environment variable. Here you can see logged in user variables and system variables. This is for every user in this operating system. I recommend set in this location. You can use anywhere. I recommend this one. Here click on new, type Java underscore home and enter variable value before bin path. Click on OK and place cursor here, type P. You can see path. Path already created. Just click on edit. Then here you can click on new, type this entire path /bin r. Click on new. Recommended is percentage Java underscore home %/bin. This is recommended because later if you modify Java path value, it will reflect here. No need to change path variable. So take this one. Let's delete this one. Use this approach for setting Java path variable. Then click on OK. Click on OK. Click on OK. Close this properties folder. Then verify Java is installed or not. Now let's open command prompt once again. Then now type Java space hyphen version. You are going to see Java version. Now we can confirm Java is successfully installed in our machine. Okay, next one. Second one, optionally install Scala 2.x. Scala 2.x is Spark supports Scala 2.x. If you want to see Spark and Scala programs also, recommended is Scala installation. It is optional thing. Here we are going to download Scala 2.x, install Scala, set Scala underscore home path variable. Then finally we are going to verify Scala. First, let me verify Scala is presented or not. Open command prompt. Type Scala space hyphen version. It is giving error saying Scala is not recognized. It means Scala is not presented. Go to any browser. I am opening Google Chrome. Then search Scala to download. Sorry. Click on install Scala. Firstly, here select the operating system which you want to install. Then see here Scala 3.x and 3.x and 2.x, and here let's select Scala 2.x. Let me click on this one. If you observe here, if you want to install Scala, Java should be present. We already installed Java. Then here you can see Scala MSI file. Click on Scala MSI file for installing Scala. Then start downloading. Then go to once you download, go to downloads location. Double click on downloaded file. Use all default options. Okay, click on close here. Open the folder. Okay, let's start installing Scale. Double click on the Scale. Choose all default options. Click on next button. Accept license agreement. Click on next button. Click on next button. Click on install. Click on yes button. Then it is started installing. Let's wait a few seconds to complete installation. Click on finish. So Scala installation is successful. Go to installation location. Go to C drive and go to C drive too. Go to C drive, and Scala is 2.x is 32-bit version. Click on program files x86. Here you are going to see Scala. In this you are going to see bin. Here you are going to see Scala commands for compiling Scala program and other Scala commands. To make this Scala commands available, set Scala underscore home and path variable. Copy path of before bin directory. Copy this path. Then go to this PC. Click on properties. Click on advanced system settings. Click on environment variable. Here click on new. Type Scala underscore home. Then enter this path variable. Click on OK. Then place cursor here. Press P key, P word in P letter in keyboard. You can see path variable. Click on edit. You can see here Scala is already added into environment variable, but recommended approach is this one. Use percentage Scala underscore home percentage slash bin. Okay, remove this one, delete, because you may have different versions of Scala. You just change in Scala underscore home. Okay, now verify Scala is installed or not. Open command prompt once again. Here, type Scala space hyphen version. Now, I am able to see Scala version 2.13.18. Now I can confirm Scala is installed successfully into my machine. Now let's continue Python installation on Windows machine for Spark. See, currently PySpark, PySpark or Spark supporting, Spark is supporting Python 3.11.x version, Python 3.11. So let me go any browser and search Python download, and click on this first link. Current version of Python is Python 14.3, but PySpark is supporting 3.11 version. So download Python 3.11 download. Okay, click on this one. Before that, let me verify Python is presented in my machine or not. So I'm using Python space hyphen capital V. Oh, it is installing Python. No Python version, but it is Python space hyphen version. Okay. Windows command is installing. So there is no Python version. See here, you can see Python 11.x versions. You can choose any one. Let's say I'm choosing this one. Here you can see, you can scroll down. You can see download location. Let's go back and let's go 13th. Let's scroll down. Let's go 9th. Let's scroll down. Here you can see installable versions, 64-bit installable versions. Okay, so click on this one, then it will start downloading. So click on 64-bit installer, start download. open the folder, double click on this one. Then here, see, we download, install, set path variable, then verify install. These install and set path variable we are doing in a single step. Okay. So here, do not click directly this one. First step 1 and step 2. Step 2. Okay. So click on add, sorry, add path python.exe to path. Then click on install. It will open a pop-up window. Click on yes button. Then it will start installing it. Yeah. Yeah. Uh, PySpark does not support greater than 3.11. So if you have another installation versions, uninstall that, install this version. Otherwise, later while writing PySpark programs, right, those programs will not execute. So to avoid that issue, if you have latest version, uninstall that, then reinstall this Python 3.11. No, Java 8. PySpark is supporting Java 8 only. Latest version also, but because we are not writing PySpark code targeted to Java, we need a JVM to run Spark software. That's it. Minimum version is Java 8. Yeah. Python is installed successfully. Click on close. Then open command prompt. Now type Python space hyphen capital V. It will show Python version now. Or Python space hyphen version. You can see Python version. Now we can confirm Python is successfully installed in our Windows machine. Now let's start setuping Hadoop underscore home should be set up. First, let me add. Yeah, Java recommended version is Java 8. If I have a latest version, no issue. Okay, now let's understand Hadoop underscore home tip. Why we are setting Hadoop underscore home. First, let me open browser. Let me open browser. Let's search Spark download. Spark download. Okay. Then click on first link. Here I am selecting Spark 3.5.8. Okay. Let's observe here. Let's observe here. Here, see Spark version I selected and choose Spark pre-built for Apache Hadoop. Pre-built for Apache Hadoop. That's it. So here it is checking Hadoop underscore home. It is not depending on Hadoop location. We say, hey Spark, I have a Hadoop. To convey to Spark, in my mission, I have a Hadoop. We are going to set up Hadoop underscore home. For this, there is a exe file, winutils.exe file. we have to download and we have to place under one folder. So first I'm going to create a folder in C drive, WinUtils, WinUtils, WinUtils. In that, I am going to create a folder called bin. In that bin, I am going to download and place this winutils.exe file. So open any web browser. I am opening Google Chrome. Then search Spark download. Okay. And click on this first link. Select the Spark version you want to install. I want to install Spark 3.5.8. So it is expecting Hadoop 3.3. So let me go to another tab. Then click on tab. Here, search WinUtils download. Here you can see first link, GitHub link. Click on this first link. Here it is expecting Hadoop which version? Hadoop 3.3. Let's go here, scroll down. Here you can see Hadoop versions 3.3 or 3.2, minimum 3. So here we have 3.3.5, 3.3.6. Click on this latest one. Then scroll down. At the end, you are going to see one file, winutils.exe file. Click on this winutils.exe file. Then here you are going to see download option. Click on this download link. Click on this download one. Then it is downloaded under Windows downloads. Take this downloads, okay, and go to C drive, WinUtils, go to bin, place this exe file. Okay, so close this one. Then set Hadoop underscore home. Under WinUtils, we have bin. Under bin, we have winutils.exe. Go to before bin directory, copy this path, then click on this PC, right click on this one, click on properties, and click on advanced system settings, click on environment variable. In system variables, click on new, then type Hadoop underscore home. Then enter this value. Click on OK, click on OK, click on OK, click on close this one, click on close this one. So now we can download it and set up Hadoop underscore home. No need to verify Hadoop underscore home team. Sorry. Now, let's start installing PySpark. Open any web browser. I already opened Google Chrome. Then I searched Spark download. I clicked on first link. I selected which version I wanted to install. I selected 3.5.8. Then here you can see Spark TGZ file. Click on this download TGZ file. Here you can see link to download. Click on this. It will start downloading into your machine team. You can see it is downloading here. Let's wait a few more seconds to complete the download. Let's clear screen. Then see here, it is still downloading. Let's wait to complete this one. let's wait to complete a download. Otherwise, you may face issue of files missing. So let's wait to show like this folder symbol here. Instead of this one, you will see this file folder symbol. Let's wait a few more seconds. So select Spark 3.x menu. Core having lot of advanced features. So because of that, some transformations may not work. Blue is different. Yeah. Mm. Now you can see folder symbol. Click on this folder symbol. Go to download location. I recommend place this file under C drive. Okay. Here, then install PySpark cooking. Right click on this one. Okay. Then you can see WinRAR extraction software injection. You may have WinRAR, you may have WinZip, you may have 7-zip. Use for any unzip software. Okay. I am extracting this one using WinRAR. Then extract here. Click on yes button. Then it will start extracting. Extraction is completed. Remove this tz file. Then I recommend rename folder. Instead of this lengthy name, give a name Spark 3. Okay. Then we downloaded Spark latest version. We installed Spark 3 and then set Spark underscore home path variable. First, let's go to Spark 3. Here you can see bin directory with the Spark commands, sbin directory with multiple Spark commands. To make these commands available anywhere, we are going to set Spark underscore home. We are going to set path variable. Copy before path of Spark before bin directory. Then click on this PC. Right click on this PC. Click on properties. Click on advanced system settings. Then click on environment variable. Go to system variables. Click on new. Then type Spark underscore home. Then place Spark path before bin directory. Click on OK. place cursor here, type a keyword, then click on edit, then here click on new, percentage spark underscore home, that is slash bin, and click on new, then again percentage spark underscore percentage slash yes bin. Both bin, yes bin contain lot of Spark to make all those commands available anywhere in our computer. We set path variable, we set uh, we set Spark underscore home, we set path variable. Then click on OK, click on OK, click on OK, close this one. Then I want to verify Spark is installed my mission on. So go to open command prompt. Okay. Then type command called PySpark. It will start a PySpark and open a Python shell. Yeah, click on allow. Then type spark dot version. So it's showing Spark 3.5.8. So now we can confirm Spark is installed successfully. It is started Spark and we executed Spark version. It is showing the version which we have installed. Now we can confirm Spark is successfully installed into our machine. So PySpark is successfully installed into our machine. Okay. Yeah. Yeah. Let's continue PySpark for AWS Data Engineering. In that, let's first PySpark program in interactive mode using PySpark shell. Uh, Let me open command prompt. Okay, type PySpark. It will start PySpark and opens a Python shell. We call this shell is a PySpark shell. Here we can write any PySpark commands. So here important points. Once you start this command, once you execute this command, you can see Spark context is created with variable called sc, and Spark session is created with variable called Spark. So Spark context, Spark session is created automatically when you start PySpark in interactive mode. Okay. Now here I am writing first PySpark program. In this PySpark program, I am going to create a RDD by loading a file and displaying count and displaying all rows and few rows. So I am creating RDD by loading local file. Let me show you sc.text file. Text file is a redefined function. For this, we pass a input path location. Let me open C drive. In C drive, there is a datasets folder. In this, there is another folder called PySpark. Here, let me open comment file. This is my comment file. Let's say I am writing Spark AWS and blue, 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 and then AWS, 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 and then HDFS. I'm changing with this one is blue, and I'm changing HDFS with Athena, Athena, and Lambda. Okay, this is my comment file. Okay, it contains how many rows? 4 rows with multiple words. So here, first I'm creating RDD for reading that local file. Then this RDD contain different functions. Let's say RDD1.count function. This count function returns number of rows in that RDD. How many rows are present? 4 rows, right? Now I want to display all rows. Then you can see uh, this collect function. So here per row, sorry, per row in rdd1.collect, then press enter, then print row. Okay, we have 4 rows, right? 4 rows, right? And these rows, select the function reading these rows in a collection form. For loop is going to read row by row, row by row, row by row in each iteration. Then we are printing each row. Let me press enter. Then press enter. You can see 4 rows are printed. Another requirement is instead of collect, we have a function called take and specify how many rows you want. I want 2 rows. Then I'm using print row. So it is going to print 2 rows. Okay. So in this, what we do, we print. Yes. Collect function returns all rows. Take function returns a specified number of rows. Yes. Correct. So for loop iterates collection values, right? It iterates row by row. How many rows we got, it will iterate each row. Yeah. So we have discussed count function. It is returned number of rows in RDD, and collect function returns all rows. We printed all rows. Take function returned 2 rows. We printed 2 rows. Okay. So clear writing this first example. Now let's continue. First PySpark program in interactive mode using Jupyter Notebook. So if you observe previous, we used PySpark command. When I type PySpark command, it is started Spark, opened PySpark cell. We return PySpark statements. Our requirement is instead of PySpark cell, I want to write it into Jupyter Notebook. Okay. So first point to tell, I do not have a Jupyter Notebook in my machine. So I have to install. Use this command to install. So first come out from PySpark cell. So here use quit function. Then here use pip install Jupyter Notebook. It is going to install Jupyter Notebook in my Windows machine because I installed Python 3.11, right? I did not install Anaconda Python. If I install Anaconda Python, then Anaconda Python gets by default with Jupyter Notebook. So I have installed Python 3.11. So that's why I am manually installing Jupyter Notebook. Let's wait few more seconds for completion of Jupyter Notebook installation. Yeah, Jupyter Notebook is successfully installed. Type Jupyter space notebook. Then it will start a Jupyter Notebook. Then open new and open Python file. Here I am trying to use spark.version. Then shift enter. When I type this one, it is giving left and right saying A Sreenivas name Spark is not defined. What we already discussed in interactive mode, Spark variable is already created, SC variable already created. But when I try to use Spark, it is giving error. So where these variables are created, when you type PySpark command, right? Not Jupyter Notebook directly. So what I'm doing, let me close this one. Let's go to C drive. Let's go to workspace. Here, create a folder, workspace folder, PySpark for AWS Data Engineering. PySpark for AWS Data Engineering. In that, I am creating one more folder, version 8. Okay, then in that I am opening command prompt. So I am typing PySpark. When I type a PySpark, it is starting PySpark cell, but not Jupyter Notebook. It is starting PySpark cell. But my requirement is when I type a PySpark, it has to start Jupyter Notebook instead of PySpark cell. For that, we need to configure PySpark with Jupyter Notebook. PySpark with Jupyter Notebook in environment variable. So there are three properties to. This is one property. Let's set up these three properties. Go to this PC. Right click on this PC. Click on properties. Click on advanced system settings. Click on environment variable. In system variable, click on new. Then enter this PySpark underscore Python equal to Python. Okay. Click on OK. Then again new. Then add PySpark underscore driver underscore Python. PySpark underscore driver underscore Python. Value is Jupyter. Then click on OK. Click on new. Then type PySpark underscore driver underscore Python underscore OPTS means options equal to notebook. Value equal to this notebook. Then click on OK. Click on OK. Click on OK. Then close this one. Now open command prompt for your workspace. Go to your workspace. Type command. Then type PySpark. When I type a PySpark, previously it is open PySpark cell. Now it is going to start a PySpark, but it will open Jupyter Notebook. See here, we got one error saying Python cannot open notebook. No such file or type. Let me resolve this issue. Type this command. I'm getting this error. Let's say Jupyter environment variable is wrong. Because of that, we are getting error. So let's rename this one PySpark underscore Python. So here PySpark underscore Python, not this one, this one. Copy this one. PySpark underscore driver underscore Python. PySpark underscore driver underscore Python. Jupyter notebook. Click on OK. Click on OK. Click on OK. Then close this one and close this terminal command prompt once again. Then go to command prompt. Then type PySpark now. Press enter. Now it is started successfully PySpark and opened Jupyter notebook. Here, click on new, click on Python 3. It will open a file. Here I am writing uh, PySpark for AWS Data Engineering. I am giving title. Then click on rename. Then here I am giving title. Then changing to markdown. Then shift enter. Now I am writing PySpark code. First PySpark code. Whatever we written in PySpark cell, same thing I'm writing here. See, first I'm creating RDD by loading a file. Then I'm printing a count. Then I'm printing all rows. Then I'm printing few rows. Okay, let me execute this program. Shift enter. Observe. So number of rows of an RDD 4, and it printed all rows. It printed 2 rows. Clear writing? How to write first PySpark program using Jupyter Notebook.